Okay, welcome to everyone. I'm so happy you're here. First, I have to do a couple of shout outs, and one is a little serious. So, if you were here last week, then you know that we started off with Dorothy Sheck giving her introduction. She has been the lifeblood of our cultural affairs since I've been here. I think this is my 28th year, ever since I've been here and before. But she's doing well, but I believe. She had a major health issue, and she will not be presenting the introduction. So I'm sure I join you in wishing her all nothing but the best. And just a shout out to the wonderful work, she helped, set up this series and so many others. So, the college has been truly fortunate to, through so many years have her efforts here. Also, this is an Orange County Community College event, and here I am, an instructor giving a series of presentations. But we often wear more than one hat, and I do, and I'm sure many of you do as well. I'm on the board of two local organizations, which, in addition to here lecturing on birds as far as lecture material, those organizations in our community and beyond are helping those same birds, and then so there's certainly a lot of overlap, and I hope. And I'm sure a lot of you, have multiple hats as well. And I apologize, every now and then I might mute someone. All right. So forgive me, I'm going to mute a couple of
each one of these things.
Oh, look at you. Thank you.
Okay. Of people here. So the Orange County Audubon Society, in addition to giving presentations about birds and are serving as a research and doing a lot of bird hikes, manages a number of sanctuaries in this area, providing habitat for birds. And so I'm on the board there. If you're interested, there's a monthly newsletter. And once again, you can go presentations and see, all of the upcoming events. Just over the border in Sullivan County, there's that incredible habitat there, and it's wonderful to see birds every time of year, especially now during migration season, the Bashakill, and there's a Bashakill Area Association, which helps manage that and protect that. But there are bird hikes there, classes there, and there are so many other organizations locally, like the Mearns Bird Club, etc. And I mention that because if you're interested in birds, I certainly am. I'm sure you would enjoy the company of others who feel the same way. And so many feel like, oh, just birding in a group or with friends, et cetera, added to this question to ask experts. So there's so many organizations around here that, in addition to giving these presentations, I encourage you to reach out and maybe find a trail near your house that you didn't know, and maybe, other birders who live near you who share some of your interests, who perhaps you didn't know. There is so much to say about birds that I thought this would be good as not a talk, but a series of talks, kind of starting from start to finish, starting with some introductory discussions last week and this week, and then just going through birds one by one, talking about their life history next week, focusing on the bald eagle specifically, but then getting into waterfowl. And then after that, other aquatic birds. And then after that, raptors, et cetera, and each week. So the schedule is posted on, with Cultural Affairs. For those of you in this room, it's on the door right outside here. And I can send you my email is walterjan@sunyorange.edu. If anyone has any questions, be happy to, answer anything that I could. The goal for today is to ask a profound question. For the longest time, our planet had 0 birds. And then there were birds. And then the question is, well, how did birds come from a planet that had no birds? And then focusing on their anatomy, because going forward, birds are special. And so here I hold up, and hopefully everyone can see that at home. I'm sure, just hold on. I think I've had issues. Yeah, good. I've had issues with cameras. So this is a bone from an emu called a syn sacrum. All right, so this is where the hips meet the spine. And when I look at this, not only is this important to birds and their anatomy and their function, but when I look at this, I'm just thinking dinosaur. Like you can see this, like there are so many parts here. So what makes a bird is not only important functionally for our appreciation of the birds we see around us today, but then just also in that story of how they got to be who they are. So I'd like to then begin this journey, and I apologize. this is unfair of me, but I'm kind of like a college teacher. And so this is kind of what I do. I'm going to start with a quiz. All right. And so I apologize. I didn't tell any of you this was coming, and that's unfair. But, once again, also as a college instructor, fairness, welcome. Come on in. That's okay. That's okay. Being fair, not something I care overly about. So question number 1 on this quiz. Is this a bird? All right. People at home, feel free. You can like thumbs up, etc. Okay. So far, just, you're doing okay on the quiz. How about this one? Is it a bird? All right.
Yes.
Next question, is this a bird?
Yep.
All right. You guys are doing great on this quiz. All right, by the way. Now, I want to ask, like, since you're doing so well, obviously, you know how to get the right answer. So my question is, so how do you know? So when you look at an animal and you say that's a bird, what makes you say that's a bird? What are some bird things that help you define bird versus non-bird? Yes. Wings, feathers, beaks, walking on 2 legs, talons. Okay. People at home, feel free to shout out, put things in chats. Tail. Okay. Tail feathers. Okay. So if you don't mind, liking birds the way that I do, I'm going to add a little more to your answers before I say, once again, no one take offense, that your answers and mine are largely not entirely correct. All right. But let me just follow in your vein. How do I identify a bird? I would say, well, I got feathers here. And a lot of the features I'm going to kind of run through really quickly with the idea that this is what will be developed much more slowly here. There's not only feathers, there's different kinds of feathers. All right, so you got downy feathers, you got flight feathers. We talked about those last time. You've got veined feathers, so all of the little the barbs stick together, and they can be asymmetrical. I'll show you what that means, but that means one side is short, one side is long, and that's an adaptation for flight. And I'm sorry. Oh, you were right here. Just go there. All right. So we have those. We have asymmetrical flight feathers. And these help so many aspects of being a bird, from their ability to fly to their being warm blood. I'm sorry, did someone else have something to say? Or okay, I might mute someone if I hear. Welcome, yes. Hi, there's a presentation on birds. You're welcome to sit down. That's okay. All right. So we got all these different kinds of feathers, and last week we talked about, there's all these different types of feathers in birds. All right. Birds have arms. All right. And it's very specific. All right. So if anyone wanted, before you leave, we have some bird skeletons here. And, and I'm sure you've eaten chicken wings. And when you eat chicken wings, if you were anatomy, minded, I'm sure you could say, oh, wait, I recognize some of those bones. There's the humerus, the radius, the ulna. But their form in birds is unique. So those are the bones inside a chicken wing. On Thanksgiving, you and someone else, you grab the wishbone and you pull, apart. Then you say, aha, birds have a wishbone, a fused set of clavicles. Here are the bones of the arm. Okay, so we'll go through all of those. They do. Oh, yeah, we'll definitely have ribs. They have interesting legs. Here's a big one. They have, in most birds, three toes pointing forward, one toe pointing back. Many of these then have digits or talons, like we have fingernails covering the digits, as someone pointed out. Not to get too technical, but a lot of the bird things are a fusion of bones. So when you look here at the skull, when you look at our skulls, you can see individual bones. But when we look at a bird, a lot of the bones have stuck together, all right, fused. And that actually happens a lot of different places, as I'll mention out. There's a mouth here, but there's no teeth in the mouth. There's a ring of bones around the eye. Here, once again, you see that toothless beak. The holes in the skull are unique to birds. The vertebrae are unique. And look at those holes. Look at the holes. We'll be stressing the holes. Birds have the weirdest way of breathing, but it is the most efficient. and to breathe the way that they do, better than I do and better than any vertebrate, they have holes in bones for air sacs which function in this respiratory system. So here you can see there are these holes for air sacs which are important in their breathing. It does. Very good. And lighter bones will also then reduce weight. They've got reinforcements of their ribs. They've got all of, just we could go on and on. If we wanted to use some fancy words, which I will just define later, there are more fusions of the bones. Their foot and toe bones are fused to form a tarsometatarsus. Their finger bones are fused with wrist bones to form a carpometacarpus. The end of their tail is fused to make a pygostyle. Their vertebrae are fused to make a synsacrum here. So we're going on with a list. So you had some features, I added some more. That's how you can identify birds. All right, so birds have these things that set them apart from everybody else. Except none of those things are good to identify birds, in that there are animals that aren't birds that have them, or maybe even in the case of dinosaurs, had them, or maybe not all birds have them today. So like one of the things we think about with birds is the big chest. So like when you're eating like a turkey breast or a chicken breast, they have a sternum as we do, but it has a big keel on it for these big flight muscles, so like all of these features, but either other animals had them or not all birds have them. So if you were saying, what is the defining feature of a bird? So you can say that is clearly a bird. It's actually a very hard question that experts would argue over. Now, not today. So you all got the questions right. You can identify a bird. But if you were to go to the early Jurassic period, there would be these things with feathers in trees above you. But telling the difference between a dinosaur that looked like a bird and a bird that looked like a dinosaur, that would be kind of tough. All right. And so where does a bird end? We could argue over this. So let's, gradually, oh, we can only see your head. Okay. Okay, I'll try to stay kind of in frame there. And be dehumanized. Okay, so where did birds come from? Well, just let's put this in the history of life on Earth. Whether it be birds or all of these other things, like humans and primates, etc. There's all these different kinds of groups. And if we were to look at geologic time, we would put it together like this. However, almost all of these things, all right, I'm just kind of talking, are in this last purple period of 500 million years. So the yellow, the orange, and the brown represent the overwhelming majority of Earth's history, and there are no birds during that time. In fact, there are no vertebrates during this time at all. So vertebrates and the birds are only in the purple last 500 million years. And then when we get to that purple time period, the first part we call the Paleozoic era, here in blue. There are no birds then. Then there's the Mesozoic era, sometimes called the age of reptiles or the age of dinosaurs, and the last 65 million years of the Cenozoic era. So when we talk about birds, okay, there are going to be no birds in any of these Paleozoic periods. The first birds are going to appear by the Jurassic, all right, and then the bird history goes on from there. So birds appeared from somewhere because most of Earth's history passed without a single bird. So where did birds come from? Well, one of the first things that was mentioned was feathers. And if we were to speak of feathers make birds unique today, but not necessarily if we consider all of the animals which are extinct as well. So there are dinosaurs which had stuff. Welcome. Feel free to join us. So when you only have fossils and you see fuzzy stuff coming off of the skin, do you call that a feather? A protofeather, a collagenous integumentary structure? Well, you can call it anything you like. But the point I'd like to make is that while most reptiles today are simply covered with scales, in the past there was a greater variety of this. Now, I'm not yet talking about the meat-eating dinosaurs, but this dinosaur was covered with some fuzzy stuff. All right. This dinosaur was covered with some fuzzy stuff. All right. the horned dinosaurs, especially the earlier ones, the psittacosaurs, were covered with fuzzy stuff. The flying pterosaurs were covered with fuzzy stuff. Now, fuzzy stuff is important. I mean, for mammals, fuzzy stuff, helps us keep a constant body temperature and warm-blooded. Birds are warm-blooded. And then some of these other animals with their fuzzy stuff, I don't know whether they were warm-blooded, all right, but certainly this might have been moving them along that pathway. So if these fuzzy things have any relation with the proto feathers, then perhaps long before there were even dinosaurs, that some of scales started to get longer and fluffier. But I would like to spend most of my time here talking about the meat-eating dinosaurs, because that's where we know we get feathers. What's the difference between that fuzzy stuff and regular hair? So I don't know in that if all you have are impressions in the rock. Like there are fuzzy things that make a mammal furry, and then woolly bear caterpillars or tarantulas, they have fuzzy stuff too. Those are bristles and not hair. So even though it looks like hair, it's not hair, and you can tell under the microscope. Because here we're dealing with impressions with rocks. Your question was, what's the difference between that and hair? I would say like with downy feathers, like kind that a baby Canada goose would have. I would compare that. But since all I have is impressions in rock, I'm really not going to answer that question well. It looks fuzzy, and I'm not sure that I can differentiate until we get to the actual fossils of dinosaur feathers, which I'll talk about in just a second. Okay. So fuzzy things go way back. But amber is the coolest thing, as you know from Jurassic Park. And I'm sorry. Yeah, before I get to amber. When we look at feathers, like I hear feathers, I'm thinking about this. Flight feathers, asymmetrical for flight. But obviously, as we talked about last week, I mean, white feathers, black feathers, they're reflecting heat, absorbing heat. Birds are doing more with feathers than just flying. They can camouflage, as this feather does. They can figure out who they want to have sex with and who they shouldn't have sex with based on the colors, so they can match up fairly well. They can attract partners here with feathers. They can keep warm. And then when we look at the little fuzzy little things coming off this thing's tail, now we're in the meat-eating dinosaurs. Little fuzzy extensions there and there and there. Or when we get to the fuzzy things there, all right, these seem to be feathers. And there are actually fossils of them preserved in amber, where some tree sap apparently caught a couple of bugs and caught a couple of this, but apparently there was one of these fuzzy little dinosaurs nearby, and amber got some of its fuzzy things and preserved it now in rock when the tree sap became amber. So these are not bird feathers in the way that there's no bird that has feathers that look like this today. These seem to be those fuzzy things on the bodies of dinosaurs, partway between a fuzzy, frizzy scale and an avian feather. Now, feathers do lots of things. All right. So some dinosaurs were just covered in, these downy feather lookalikes, which I don't know what it was using it for. But if I were to make guesses, I mean, it probably would have been helping keeping it warm. All right. Maybe it was using it for camouflage or to attract a mate. Maybe it was using it to distribute heat differently, the way some birds absorb light or reflect light. Birds use feathers for a lot of things. And what this dinosaur was using its fuzzy stuff for, I'm not quite sure. This one had some on its tail. We're getting into the Tyrannosaur lineage. All right. And so this is a relative of Tyrannosaur. It was only about my height, so it wasn't one of the big Tyrannosaurs, but it's covered in fuzzy things. This was a pretty big time at Tyrannosaur. You see some people assembling its skeleton there. You can see some fuzzy things there. And so the point is, even before we start talking about the flight feathers, and I do want to talk about flight feathers in just a little bit with the dinosaurs, but a lot of the dinosaurs, even some flying reptiles, were fuzzy. So whatever scales could do, apparently some of them can become frizzy at the end, and who knows what that was doing as far as thermoregulation, etc. So for a number of reasons, we start to link theropod dinosaurs with birds. Now that's number 2. Here's number 1. Now, we don't have to stress this, but if we're going to name a biological group, somewhere there are rules. Somewhere someone has sat down and said, if you're going to use this word, the name of a group, what are the rules? Why do you call that thing a member of this group? What traits does it have? All right. So people have meetings about, like, if you're a meat-eating theropod dinosaur, why? What do you have? Because there's rules. So if you find a bunch of dinosaur bones, you just can't say, oh, I found a dinosaur. I found a meat-eating dinosaur. No, you have to say, prove it. It has these features. That's what makes it a dinosaur. It has these features. That's what makes it a meat-eating dinosaur, etc. So we could start asking these. If you ask, what makes a meat-eating dinosaur a meat-eating dinosaur? I'm doing the quick overview of videos on my YouTube channel at Dr. Jan41. Certainly, you could, go here and, see the longer versions of this. But if you said a meat-eating dinosaur, what makes you that? If you found a bunch of dinosaur bones and you say, I want to classify as this, here are the traits. All right, and you can say, aha, it's a meat-eating dinosaur. Oh, okay, I'm sorry. Yeah, no molars yet. That's a mammal thing. But good question. The ones here in purple, those would be some of the traits. But birds, at least first birds, also have those traits. So if you're using it to say these bunch of bones are a meat-eating dinosaur, then just a bird skeleton, certainly the first birds, would fit into that category. And you say, all right, well, then there are different groups of dinosaurs. So like from the meat-eating dinosaurs, we then get the neotheropods. That would be the next group. All right, so in addition to those features, they would then have more features that would define them as being to this subgroup here. See all the purple. But birds, at least the first birds, also have those features. So if that's what's defining the group, and you're going to say, here's a bunch of bones that belong in this group because of this, then birds go in this group. And you may guess where we're going. All right, then the next group, the same. Then the next group, the same. Because then this family tree, we could have all of these little branches. After the neotheropods, we could say, the next group, you're the tetanorans, you're the maniraptorans, etc. We can just go on and on. And each one is defined by certain features. And birds, at least the first birds, have those. So if we're classifying things in groups based on the features that they have, then birds are meat-eating dinosaurs. Specifically part of the neotheropod group, and then specifically part of the tetanoran group within that, and then specifically part of the maniraptoran group within that. We could go on and on. Now, that's just fascinating. However, we want to talk about what makes a bird a bird. So when you get to some of these groups, like the Avetheropoda, there is a group of dinosaurs called Avetheropoda. Theropod meaning meat-eating dinosaur, Ave meaning bird. So clearly just the name of the group is saying not only are there meat-eating dinosaurs in this, but also the birds. There are feathers by this point. There is a unique wrist bone. There are fossils of dinosaurs brooding over a nest of eggs, the way that birds do. All right. And all of these other things that will make birds. These aren't arbitrary features. Spaces in the bones, like you had mentioned, not only making the skeleton lighter, but which will also provide extensions for air sacs to make birds' respiration better. That's a feature of birds today. You can use that to identify birds, but the dinosaurs invented it. Okay. And so many features like that. And we could go on and on, but flight feathers come of interest. So flight feathers are different from the downy feathers, right? And so we associate them with flight, but it turns out you can have them if you don't fly. And certainly some of the dinosaurs did. All right, so here's one called Caudipteryx. It had, quote, flight feathers, but it couldn't fly. It was too heavy. In fact, and actually some birds did this as well, in addition to other animals. If you don't have molars to grind up your teeth and you want to grind up your food, well, you've got options. Birds have gizzards. We'll mention those. But you can also eat rocks. And then in your stomach, when your stomach churns, the rocks can help grind this up. So this dinosaur had rocks in its stomach called gizzard stones or gastroliths. And it couldn't fly because its body proportions were wrong. Plus, it was eating rock, so it's not a flyer. But it had flight feathers. All right. So if we start looking at the next groups of birds, so for all of these different groups, and I want to get to fun, cool stuff. So and not spend all time on all of this naming, but for each of the groups, the maniraptorans, et cetera, in red, we could say, what does a dinosaur have to be a member of this group? And if we look at the first birds, you could say they have that. All right, there are dinosaurs, once again, that brood over their nest. There are dinosaurs now that have wishbones. All right, today, a wishbone, you can say, oh, that's a bird thing. The non-birds don't have wishbones. A wishbone is a fused pair of clavicles. But some of the dinosaurs have that. And then some dinosaurs had flight feathers. Here you can see some on the tail. All right, so here's another one. This one doesn't have the flight feathers. All right. But here's some extensions of flight feathers. You can see some in there and in there. Here you can see some on this one's tail. All right. So not just having feathers, like downy feathers, but then also having flight feathers. As we get to the top of this family tree, the Velociraptor kin, more flight feathers. Velociraptor, we don't have feathers of Velociraptor from Jurassic Park, but if you look at an arms bone, you see these dimples, which you can find on bird arms, that's where the flight feathers attach. All right, so it's quite likely that Velociraptor had feathers. This one, not only did it have feathers, we know what colors they were because the pigment molecules were preserved. They were mostly black with some little white stripes and a little reddish-brown crest on the head. All right. So here we have feathers. Here's an interesting one because there's a couple that don't have feathers, but they have really long scales. Maybe that's where feathers come from. All right. So scales that just got long and then fluffy at the end that, going back to those images I showed you earlier, maybe that's how feathers started. And there are some dinosaurs which have feathers like that. So most of those couldn't fly. But a couple maybe could. And here's where I don't want to get judgy. And at a certain point, I have to be judgy. So I don't want to go there. What's the difference between gliding well and flying poorly? Well, that's a judgment call. All right. And so a lot of the things that I showed you, gliding to some degree would have been certainly possible. And when I say gliding, even short term, this is something. What I'm about to say, I totally made this up. So I've never read this in any sort of scientific article, or this is just totally my imagination. But going back to Caudipteryx, why does it have flight feathers on its arms and its tail? I have no idea. But a lot of members, so what I'm about to say, I'm making this up. Maybe it's to attract a mate, you can always say stuff like that. Maybe if you have long feathers off your arms and you're trying to scoop up a little running lizard or a rodent-like thing, it kind of creates a basket that helps you gather it, maybe. But in the Velociraptor group, which is really closely related to birds, they have sickle-like claws on their feet. All right, you've seen Jurassic Park, I'm sure a lot of you, so you know that they've got these weapons on their feet. Now, I think if I was trying to provide for my family and I had weapons on my feet, my family would starve. I mean, there is no way I'm running after a deer, and right before I get there, I jump feet first, slash at it, all right, that I'm going to bring it down, but then B, land so that I don't kill myself, or if the deer turns around with its antlers, I'm going to run away. I'm not that dexterous with my feet. But these feather things would help. Your jumps would be prolonged. You could steer in midair. I don't know that. I can't prove that. But even though we say these are for flying, even if you can't fly, that would have made you, a better jumper. And then when you get into things like Microraptor, interesting. A lot of people want to change the name of Microraptor to Tetrateryx, which is the forewing, because it has flight feathers on its arms, its tail, and its legs. And interestingly, so did the first birds. That's been noticed for a while, but no one really gave it any love. It's oh yeah, they also have flight feathers on their legs. Oh, who knew? Goofy. And then no one would talk about it anymore. But now some of the dinosaurs did. So apparently one of the ways that they would glide would be not only using, these elongated feathers on their arms and tail, but also their legs. So this was certainly a glider. It certainly had some modifications of the foot, adapting it to live in trees, although not a perching foot yet. So it's small. There were different species of this. One, if you don't count the long tail, you could have held in the palm of your hand. The tail would have been longer. So, I mean, they're dinosaurs, but these are little guys adapting to life in trees, capable of gliding and maybe flight. So there's a couple that if you ask, could they fly? Once again, if you're gliding and then you just do that, is that flying badly? Like, this is a judgment call. And I leave you, when you leave here, you can all have coffee or go out for a drink, and you can judge, and you can, say who glides and who flies. But there were a couple whose arms were so long that, you know what? They could have flown a little bit. Now, not well, not like a bird that like push its wings down and it's airborne. But the first birds couldn't do that either. So a lot of things, like, have you ever seen a Canada goose take off? They're running, they're flapping, and it takes a while. Cormorants would do the same thing. Or maybe they climb up a tree and jump, and just the height helps them do it. So these things would have needed to do something like that in order to get airborne, and they wouldn't have been flyers the way that modern birds are. But the first birds weren't good flyers either for millions of years. We'll get to that. So there's more stories to tell. So I want to jump into those stories, but I'm sorry. I mean, I keep changing which videos I say. This would be the perfect video for you to see right now. But, oh, yeah, here. Suffice it to say, I do want to get to, like, specifically the arms, etc. But if you were to take the hand of a dinosaur, and if you were to then take the wing of the first birds and say, how do they stack up? Well, interestingly, they have the same bones. In fact, let's color them. They're the same bones. And there's some weird ones, like a weird semicircular bone that the count of the digits here, they're identical, except the birds are just longer and thinner and lighter. So what makes an arm a wing is really, it's like the ostrich. Yeah, very good about the ostriches. Oh, and there was a question, how could they tell they have protofeathers from fossils? And that was just, you saw some of the fossils that had the impressions of them. And so a lot of these, the features, bird wings aren't made of anything fancy, just the same bones that you have. All right, so if you know the bones of the human arm, all right, you can say, oh, here's the scapula, here's the coracoid, here is the humerus, here's the radius and ulna, here's some wrist bones, here are some digit bones. Of course, they fuse together. If you were to say, what muscles do birds have in their wings? Well, you won't be that impressed. They have a biceps brachii, they have a triceps brachii. All right, they have some of the same forearm muscles that you do. All right, and so by the time we get to the end of, like, our little dinosaur family tree, you've got the same bones in dinosaur arms and the same orientation. Like, if you look at the shoulder blade of a bird, it's weird. It's like this thin strip. But if you go to the Museum of Natural History and look at, like, Allosaurus or Tyrannosaurus, it's the same scapula. All right, so dinosaurs had evolved the same arms as we would see in the first birds. And here, so meat-eating dinosaurs. So today there are meat-eating mammals, for example. How big are they? Well, we think of lions and tigers and bears because we'll answer your question. Because, like, they jump to mind. But then there are, like, weasels, and all of these mammals which are eating smaller things. And among the meat-eating dinosaurs, it would be the same. Like, Velociraptor was maybe your size. Its cousin, Utah raptor, was much bigger. Tyrannosaurus, huge, but it had cousins, especially the earlier versions, which were my size or smaller. And so Velociraptor is bigger than a modern bird, although smaller than the ones you see in Jurassic Park. They kind of exaggerated the size of Velociraptor. I have somewhere's Velociraptor here. Darn it. All right, I'm sorry. I had pictures of Velociraptor. And so in this group, like this is bigger than a modern bird, but some of these like would be like turkey size. There are some which would have been crow size, like Anchiornis would have been probably a little smaller than a crow. So just like meat-eating mammals, they come in multiple sizes. There are certainly big meat-eating dinosaurs, but there were smaller. Of the these feathered ones, they were smaller as well. All right. Somewhere. I guess that's the next one. Okay. So I don't know how well you know your dinosaurs. All right. Does anyone know which meat-eating dinosaur this is?
Pterodactyl?
No? That's a good guess. They were actually cousins of the dinosaur group. They branched off earlier. Anyone?
Velociraptor.
Good guess. No, actually, this is the first bird, Archaeopteryx. All right. And so if you had trouble distinguishing between them, like no fault to you, because people argue. There have been fossils classified as dinosaurs, which are now classified as birds, and vice versa. And you could find arguments like, all right, where in the family tree do we draw the line and say this is a bird, not a dinosaur? After all, if we were to just go to the oh, they've got multiples. Yeah. And so is this, get out of my way. Yeah. So I forget, are you at the end or at the beginning? All right. So I have videos. In the interest of time, let's just kind of hit the highlights. But if we were to look at the skull of Archaeopteryx, it's fascinating. There are features that are birds. We classify it as a bird. And if you said why, you can say, look, here are features that the dinosaurs don't have. All right, the shape of this bone, the shape of that bone, there are features that the dinosaurs don't have. But then it also then had teeth. It had sutures between the bones that modern birds don't have. It had the holes that modern birds don't, but the dinosaurs do. So we could go through this skull and show you both features that remind us of birds that dinosaurs don't have, but also features of the dinosaurs that modern birds don't have. It has teeth, something that modern birds don't have, although there are some mutant chickens which can make teeth. That's interesting. We can get back to that. If you look at its arms, this is what clearly makes it birds. They're so long that they could function as wings. Some of the other things, they would have been gliding at best, but this could actually function as wings. Maybe a couple dinosaurs also had it, but this one certainly did. But there are claws on the end of its grasping hands. All right, so this one could actually pick things up and catch things with its clawed hands. It has a long reptilian tail. So by the middle of the Jurassic period, by the middle of the Jurassic period, we can stop talking about dinosaurs that look like birds, and we can talk about birds. All right, so this is the age of dinosaurs. We split it into 3 periods. By the middle one, the Jurassic, Earth now has birds. But they are not ducks, they are not hawks, they are not bluebirds, they are not sparrows. They are no bird that is alive today. They look like this at first. And as we look at these fossil birds, once again, they're birds, flight feathers capable of flight, but clawed, grasping fingers, teeth, long reptilian tails, and extinct today. They have tens of millions of years to become more like the birds that we think of. All right, so this is a long journey. All right, one of the first things on the journey is they realize we have to lose the tail. All right, the tail is just not helping us. So while the very first birds like Archaeopteryx and then a few other ones have really long tails, one of the next things we notice is that the tail shortens and the end of the tail fuses. I used a term earlier, I said was a pygostyle, where one of the things that defines a bird is it fuses the end of its tail to make a solid bone, form a pygostyle. Well, that happened very early. The first birds didn't have that, but very shortly after that, they did. Okay. And then there are, let me just keep on showing you pictures of these. All right, so the questions of the skeletons of Archaeopteryx, we are lucky enough to have multiple skeletons of Archaeopteryx. Recently, they just found another complete one. Once again, the tails start out different, longer as opposed to more fan-shaped here. So there were some long-tailed members at the beginning before they developed this Pigo style. Some of these then get small. So this thing probably a little bit bigger than a sparrow. All right, Confuciornis. But look at the clawed grasping fingers. Look at the teeth. Like it's a bird. All right, that's not a tail anymore. That is long feathers, but it seems only in males. So there are two fossils, two types of fossils in this group. Some have these long tail feathers and some don't. So in birds alive today, we often see a distinction between the feathers that the males have and the feathers that the females have. So this goes back to the early Cretaceous. We can see other birds having similar things. Okay. Now, they're good. We got birds. I'm happy. You're happy. However, in the Cretaceous, there gets a new group of birds. So there's a family tree, and there's like all these offshoots. But in the middle of the Cretaceous, for the first time, birds get good at flying. The first birds weren't that good at flying. All right. But then they make a number of changes which make them better at flying. I list them here. All right. I have videos where I kind of go more on the anatomy of these. So if we were to look at the shoulder of a bird, all right, here's an alligator. There's a thin scapula. There's the procoracoid. If you look at Tyrannosaurus Rex, thin scapula. There's the procoracoid there. And then if you look at birds, here's a toucan, obviously thin scapula, etc. But then there are modifications in this new group of birds of this scapula. So that you've got three bones coming together. The procoracoid, the wishbone, and the scapula are all unique now, including there's one of the really unique things that appears now for the first time. Birds, once again, they start to get better at flying. So the first birds could fly. They just weren't great at it. All right. Here's the big chest muscle of the birds. The first birds didn't have big chest muscles. All right. So they would have had to like run to take off or jump out of trees. They couldn't do this because they just, didn't have the big chest. Bird flying is impressive, but I'm not like super impressed because just, I hate to brag, but like if I had a sternum that came out to here and if my chest muscles were out here, guess what? If I did this, exciting things would happen too, right? Like you would too. If your chest muscles were out to here and you did this, you would do stuff too. All right, so these big chest muscles, they're impressive. And that's what brings the wing down for the downbeat. But the question is for the upbeat. Now, here's a problem, because if you're flying, especially if there's wind or resistance, you need to do this. And you'd think that this would then have to be above the shoulder, all right? But then the heavy thing is now every time you try to fly, you're fighting this big muscle that's over your center of gravity. Where is the bird muscle that pulls the wing up? It's under the wing, here. And it's actually a homologue of some of our rotator cuff muscles. So how on earth could it do that? And the interesting thing is, even though the muscle's down here, its tendon comes up and over the shoulder through this little hole thing so that it can pull on the wing from above despite being beneath it. My point is, that's very clever. First birds didn't have that. That developed over time. And then they got better at flying. Okay, we could point to all of these other things like this new group of birds I'm talking about. They modified their ribs. There's just reinforcements there, like wide base processes. Because if you've got this really light skeleton and you're flying, and you're exerting a lot of force, these muscles are attached to ribs. You need to reinforce the ribs so they can stand the forces. And so you see those little Y-shaped structures. That was new in this group of birds. Plus, birds have what are called sternal ribs. So we have ribs that go down from our vertebrae towards our sternum, and there's cartilage here. But then birds then actually have ribs that go up too. So here are ribs going down. Here are ribs that go up from the sternum as well, just making this thorax just solid and stronger to withstand the stresses for flight. The sternum starts to get big. All right, so when we look at my sternum is flat, all right, but birds start to develop what's called a keel on the sternum, starting in the group that I just started talking about. So now the sternum is going to come out to here. The chest muscles are going to come out to here. Once again, that's going to make them just much better at flying. All right. One more example, and then we'll kind of go on because this is kind of more the overview. The first birds could fly, but they weren't great. And one of the reasons is if this is my center of gravity and I'm a bird, this is where I want the weight. All right. If the weight is other places, then I just have to resist that. And now I just need to put more energy into flying. So like teeth, if I've got a long birdie neck and I've got teeth in it, teeth are heavy, that's far from my center of gravity. And everything that I like, every wing beat that I take has to lift that. So later groups of birds lose the heavy teeth away from the center of gravity, but now use a gizzard, which is a modified area of the stomach to grind the food. Like turkey's bread can take a walnut and do that with it and crush it in their gizzard. Like I can't do that with a walnut. All right, but this gizzard is strong. Like what I'm using my grinding molars for. All right, birds are doing here, but the gizzard is at their center of gravity. They lose the long reptilian tail, once again, moving to the center of gravity here. The muscles which raise the wing are under the wing, moving the center of gravity here. So birds start to get really good at flying with this new group that evolved. And they've modified their thorax a lot, hence the ornithothoraces group, the bird thorax group. And this group then splits into two. All right, so by the end of the Cretaceous, there are two groups of birds on our planet, and they're flying pretty well. They still mostly have teeth. They still have claws on their fingers for the most part. You don't have to know the names, obviously. But of these two groups of birds, the ones on the left, they're the most common. They're the most diverse. They're all over the planet. There are vulture-sized ones. There are sparrow-sized ones. And you've never heard of them because they're all dead. So when the dinosaurs died, it wasn't just the dinosaurs that died. A lot of other things do, including the most common birds on Earth. All right. So the second group, the minor group of birds by the end of the Cretaceous, they're the ones that survive and are the ancestors of the birds we have today. So birds were doing great in diversifying, but just in ways different from today. Once again, there were still no Tyrannosaurus rex ever saw an eagle, all right, or a parrot, or a woodpecker, or a sparrow. All of these come later in the age of mammals. And the birds that the dinosaurs were dying, most of them die with the dinosaurs. Okay. Now, all right, before we start talking about modern birds, which is obviously a good place to go, I wish fossils were perfect, and I wish we had just every salt anatomy piece of every dinosaur, and we don't. Somewhere along the way, birds got really good at breathing. And just here's a quick demonstration of how birds breathe. If you were to say, how do birds breathe? We're going to have to follow 2 inhales and exhales. If you're looking at me, just inhale, exhale, and you're done. Birds, we're going to have to do that twice before we can figure out what's going on. They inhale once. Does the air go into their lungs? No. It goes into air sacs in the back of their body. Okay? Then they exhale the first time, and now air goes into their lungs. Then they inhale a second time, and then air is going into air sacs in the front of their body, and then they exhale the second time, and air leaves, which is far more efficient than what I do. Because when I inhale and air goes into my lungs, there's air here in my trachea that my lungs never touch. So they never get this oxygen. There's oxygen here, but it's not in my lungs. This is my trachea. So that's oxygen I will never use. But in a bird, every bit of the air they inhale goes through their lungs. So that's just far more efficient. And the air sacs which make this possible, we see holes in the bones going back to the dinosaurs. So once again, some of the bird features predate the birds, right? Or at least they modify things that the dinosaurs have. I'll get to this at the very end. See the little pink box? It's called the syrinx. If you look at it in like a dissected pigeon, I teach comparative anatomy and we dissect things. It's not impressive. Does it stand out? It doesn't. Um, but this is important when I get, it's what's called the syrinx. And the muscle contractions here are what allow the songbirds to be songbirds. So when we think of birds, we say, ah, what beautiful songsters. I'm sure a lot of you have heard great blue herons sing. Yes, great blue herons, beautiful songsters. Anyone? No. Eagles aren't. In fact, I forget, there was a movie on last night. What was it? Like eagles, they don't sound good. And we know this because if you watch TV, like there'll be a Western movie or there'll be shows. There was just one last night, I forget what it was. And you hear there's an eagle sound, but it's not, it's a red-tailed hawk. We like red-tailed hawk sounds. And when we like have an eagle in a movie, we put in the red-tailed, we don't put eagle sounds in for eagles. But anyway, most birds don't sing the way that, you know, the warblers do and all of our songbirds. So this would be the last big group of birds that modify this. So just, you know, the bird anatomy develops over time. Birds have a four-chambered heart, just like mammals do, but they do it a little bit differently. Right, so the avian heart has four hearts. It's a little bit different. They're weird. If you ever park underneath a tree and then you have white stuff on your car afterwards, you're like, oh, this bird pooped on my car. And you're not wrong, but it's probably more urine because birds excrete a white powder as their urinary waste. All right, so that's, you know, probably a 20-minute talk in and of itself. So we don't necessarily have to go there. But there's just fascinating stuff which happens. So like when birds make their urinary waste, and if you're into anatomy and you know peristalsis, we think of like peristalsis of moving like urine like away from the body so it can leave, or like feces away from the body so it can leave. What birds do is from the ureters, urine gets here, and guess what? It does reverse peristalsis. It goes into the body. It doesn't leave, and then it goes here, all right, where then it can extract some water and dissolve it. So now it makes a white powder that when it finally gets excreted, they've conserved water and they excrete urine differently. So when we talk about bird anatomy, there are so many things that make birds unique. But so many of them, especially the ones we can trace with the harder things that we can find in fossils, either A, dinosaurs already had them, all right, or at least to some degree, or B, the first birds didn't. So a lot of the really cool things about like the bird skeleton, like the keeled sternum, the adaptations of the thorax for flight, the fusions of the bones of their legs and in their arms, that took a while. Birds didn't have that at the start. That would be later groups of birds that did that. All right. So where does that leave us when that big rock falls out of the sky and so many birds become extinct? Well, the most primitive birds alive today, they must have been around by the end of the Cretaceous, even though we don't have their fossils. All right, so if you were to look at the family tree of the birds alive today, what's the first branch? It would be the branch that has ostriches in South America, rheas in Australia, emus and cassowaries, and also in South America, a group of flying birds, because everything I just said doesn't fly, but there is a small group of birds in this group that can fly. So they're alive today, and for reasons I'll explain in just a second, they must have already existed by the end of the Cretaceous. So, you know, Tyrannosaurus rex and friends could have seen the ancestors of like ostriches and this branch. Who's the next branch of the family tree? Well, it's good we're ending. This has undergone radical revision in like the past 10 years. And one of the big things that has changed classification in the past 10 years is when I first started teaching, the anatomist ruled. You would say, look at this anatomical feature. Based on this, we will make this group. We will define our we will define our taxonomic groups through their anatomy. Anymore, everyone says, oh, forget the anatomist, those old, they don't know what they're talking about. Let's just look at the genes. All right, and that's all they do. The computer analyzed the genes and it says, here's the family tree, so here's the family tree. Now I teach anatomy and I love the anatomy. I teach genetics, I respect both. And sometimes the genetics goes too far and we're still trying to figure it out. So much change occurred in so little time. But one of the big things which has held up is the next branch of birds is gallo-anseriforms, which are chickens and ducks. So chickens and ducks are a branch of the family tree of birds, which would predate, the hawks, the woodpeckers, the songbirds, etc. They will come later. And then if you were to ask, who is alive when the rock falls out of the sky that wipes out the dinosaurs and so many other things? Well, most of the orders of modern birds, they pop up in the fossil record here, all right, and some much later. But ducks, maybe there were duck-like things that existed at the end of the age of dinosaurs. Okay, and sorry, I have so many videos. Now, when I say ducks, I'm kind of being generally, like, it seems duck-like, like there's a duck-like bill, but a lot of the earliest birds had long legs. So the first ducks had long legs. The first hawks had real long legs. The first vultures had long legs. But there are fossils which seem duck-like of the galliforms. Oh, that would be the chickens, I'm sorry, and anseriforms would be over here, that seem to predate here. So the best analysis that we can come up with is, if this is when the dinosaurs died, that by this point, there was at least some branching in the ostrichria group, there was some branching in the chicken group, and in the duck group. Once again, maybe the ducks had long legs by this point. And then some other ancestor of all of the other birds here. So if you care, and I can tell that you do, if you ask why do we say that the ostriches and the emus, et cetera, are primitive, the answer is the bones in their jaw and the roof of their mouth. So we split birds based on, so here would be anatomical features speaking. There's the old mouth birds and the new mouth birds. Old mouth birds would be like an ostrich and a rhea. And if anyone cares, I got a video going through all the bones, et cetera. All right. So we don't have ostriches. We don't have emus here. All right. But we do have the ducks and the chickens. So they would be the most primitive group of birds in Orange County here. And we could argue about how much of their diversification occurred right before the end extinction or right after. And so there are fossils, but bird skeletons are hard to come by anyway. I'm sure you know that. I'm sure you've seen far more deer skeletons than birds. Once you do, the bones are so small. All right. It's so easily crushed, et cetera, and not often fossilized. We just don't have that many fossils of birds, and certainly not good ones to go by. So, a lot of this, people can say, like, I used to think this was a penguin. Now I don't think it's a penguin anymore. I think it's a cormorant. And so it's a little bit of tough. And the genetics is hard because so much was changing so fast. Like when the rock fell out of the sky and 60% of life died out, including the most common birds of the day, then all these other birds said, hey, all these habitats are for me. Let me change over a very short period of time. And that's where the genetics get sloppy. The genetics can really help us distinguish between branch points in a family tree if you have very gradual stuff happening from long periods of time. If a lot's going on in a short period of time, yeah, just have a little less faith in the genetics. All right, but so the ducks and the chickens are old. One other thing, not that we had too many of those, when the dinosaurs died, that also meant Earth lost every one of its big predators. There are no more big predators on Earth. Now, mammals will essentially say, hey, you know what we could do? We could do lions and tigers and bears and all of these other things. But birds do it first. All right, so there were birds which were 6 feet tall, were 9 feet tall, were up to 16 feet tall, like the moas, which actually humans encountered when they went to New Zealand. And so all throughout the world, there are no big animals eating things. And so there are big birds, which are the dominant predators when this new age of mammals starts. So the last 65 million years after the dinosaurs die, we break into a Paleocene, an Eocene, an Oligocene, a Miocene, and then the more recent times. Birds are the first ones to say, hey, we could be big and predators too. And all over the world, there are what are called terror birds. All right, some have the skulls the size of horses. And speaking of, and I'll get to you in a second. Speaking of horses, not that long ago, like I think it's like 6 million years ago, Florida had a 6-foot giant bird, but then they also had horses at those days, but they were like little three-toed horses. So Florida, not that long ago, like birds were eating horses, and so that's something we often don't think of. Some of the flying birds were big as well. There was birds related to condors. Condors are the largest flying birds alive today, but they had bigger cousins. In the west of the United States, there were teratorns that could have wingspans up to 18 feet. In South America, one could go over 20 feet, maybe eating like dead mammoths and the like, or dead elephants and the like. So certainly that's fascinating. I'm sorry, we had a question. Yeah, eagles do sound like seagulls. You're right. Thank you. But if you were to now start saying, all right, well, let's pick bird orders. Where do the first woodpeckers come from? Where do the first parrots come from, et cetera? Well, it's all since the age of dinosaurs ended. All right, so if we were to say, oh, it's like the first fossils go back to, the Paleocene, 65 million years ago, or the Eocene 55 million years ago, or et cetera. But, here the first woodpeckers known since the Miocene. But birds don't fossilize well, and certain habitats don't like tropical forests. You don't get fossils from there, and so if you're going to go from fossils, your bird fossil record is going to be sketchy at best. Like, when did the first woodpeckers come from? You can say the first ones we know of are from the Miocene, but like, when were the first? Were they earlier than that? Just tough to say. And once again, we do like the genetics to help us, but so much was changing so fast that, as a geneticist, maybe genetics aren't quite as, the most reliable in that sense. All right, and so as far as the modern birds branching out, we have ideas of the order of things, but to be honest, fossils of birds aren't great. The genetics of most recent events not that great, and so in general, we think the family tree looks like this. We have the chickens and the ducks. We have other aquatic birds. We have woodpeckers. In there is the raptors. And before I get to the very last group, if anyone reads up on this, you would like me to stop talking because you're angry, as I am. All right, because if you say, what does the family tree of bird look like? I'll be happy to give you an answer today. Come back in 2 years and I'll say something different because some new study gets published. We analyze more genes and we've done this now. So what's a raptor? I don't know. Are falcons raptors? Not anymore. Not anymore, because they studied the genes and they say, oh, they're not related to hawks anymore. They're in this group over here. Oh, and are the vultures, they're a group? No, they're not. There's two different groups of vultures, the old world vultures, the new world vultures. They're not really related. Oh, and owls. Owls aren't raptors either. They don't belong in this group. So, I mean, this enrages me because I develop notes that I teach my classes, and I develop these videos, and then a year later I have to make a new one, because it's wrong now. And so if you've been following this, and anyone who studies this, it just, like the past 10, 15 years, there have been so many proposals, but that's what science does. Here's an idea, here's the evidence for it. Good, okay, let's think on that. Now let's test it a new way. All right, I support this part of your idea, but now this part, maybe we tweak this. There's new evidence. So that's also science working at its best. I'm not really angry, but I certainly don't want to say here's the rigid order of things. But what I can say are the most successful birds alive today are the songbirds. And they were the last big group to evolve. All right. So not only have birds not always existed and developed slowly over time, but the most common birds, the same would be true of those. Before there were the songbirds, which we call the Oscine passeriforms, there are things like flycatchers and a lot of things in South America, which are called the suboscines. So even with the songbirds, we have the order of the songbirds, but then we have this mostly South American group. Now, yes, we have flycatchers, but nowhere near as colorful and as pretty as all the South American ones. And so then here in the very last group, they're very small. They have that syrinx to make sound, often very colorful, which has helped them, produce so many different species, etc. Once again, birds don't go way back. And one of the cool things about sandhill cranes, which we have in Orange County, we'll talk about these in 2 weeks, or no, 3 weeks, when we do aquatic birds. But this is down at the Liberty Loop, where the Appalachian Trail is at the border of Orange County. They've been there for years. They've been, raising chicks. That's great. Among all the cool things that we can say about sandhill cranes, we can say that there are fossils of sandhill cranes known which are more than 2 million years old. That's about as old as the birds we see out here go. So if you say, are there 5 million-year-old blue jays? There aren't. Or cardinals, or sparrows, or warblers, or no. So not only did no dinosaur ever see a hawk or a woodpecker or a sparrow, but if you were to say the blue jay, the white-throated sparrow or whatever, these things are very, very recent. And in fact, just like 2 million years, which out of the 65 million years since the dinosaurs went extinct, that's a tiny fraction. That's about the oldest bird alive today that goes back to this point. Now, I have all of these videos that go into like the wing muscles and the bones. This was just kind of, a quick overview. But I think the take home is, it's a wonderful story. Our planet didn't have birds, and then you come back later and it does. Where did they come from? And it turns out like a very gradual set of changes where a lot of what we refer to as bird features that you would say, aha, today that's a bird because it has these bird features. Turns out a lot of the non-bird dinosaurs evolved them first, and birds just modified them. And then the first birds didn't have a lot of the features that we associate with birds today. They weren't all that good at flying. So bird nests took tens of millions of years to develop very, very slowly. And as we look at the great diversity of birds which we see around today, these are all the living remnants of all of those branches of the family tree. And in this series of 15 lectures, I wanted to kind of talk about feathers and color in the first week, and then just how birds got to be birds in this week. And then the last introductory lecture is most birds share a life history. Like they hatch from an egg, and then they grow as infants very fast, and then they do this. And so I thought, well, why not talk about the life history of birds in general, but focus on a specific one? How about like the bald eagle? So because bald eagles are worth talking about for, an hour, but also using them as an example of a bird life history. And then after that, we can go into the ducks for a week and other aquatic birds for a week and raptors for a week. So I'll answer any questions that you have. But thank you so much for joining us. I'm recording these. I'll post these online and keep them here. And once again, my name is Dr. Jan. I have a YouTube channel, Dr. Jan 41 on YouTube. So there's a lot more information here if you were interested. Let me just hit the lights, and then I'll answer any questions. Yes?
How many birds that have only appeared like a million years ago, like modern birds?
Ooh,
The
you know what?
blue jay, the cardinal you brought up.
The
White neck, you said?
like a white-throated sparrow, just as
Yeah,
an
white
example.
bird.
I would feel dishonest if I even attempted to answer that. The reason is, we just don't have fossils of birds in places that fossils are forming. And then there are just so many places like tropical rainforest where most birds live, by the way. We don't have fossils at all. So the only way to answer that is if I were to say, here's a fossil of this blue jay from 1 million years ago. But we have just such a sparse record. I don't think I could give an answer that would be accurate enough to, so I'm sorry for that. Good question. Anybody else? Yes. Ooh. Mm-hmm. Interesting. Certainly there are especially humans are changing habitats, climate change is changing this. We might be getting new birds coming in this area. So maybe seeing more ravens other than crows, maybe, the black vultures. Certainly as we look throughout the world, like the bald eagle will come up. How big is a bald eagle? Well, it depends. You're talking about the Alaska bald eagles? You're talking about the Florida bald? Oh, thank you. Thank you. Oh, thank you. It was wonderful to have all of you.
Also, you
are we
have to
talking
repeat the
about,
questions.
the Baltimore. Oh, the question was, are birds getting bigger? In Florida, they're getting smaller. Whereas, Alaska, like they're much bigger. So I think like in certain circumstances, birds are getting bigger, especially where it's colder up north. And if they're, going to different parts of the world, but in other parts, they're getting smaller. And so I think it would be a mixed answer at best, would be my guess. Yes.
When you say up north, they're getting bigger, why? Why? bigger
Well,
up
we
north,
see
not
that,
down south?
we see that a lot. Like if you were to take bears, where do you find the biggest bears? Is it in, Florida and Georgia, or is it Alaska and the Yukon? It's up there. Where you see the biggest deer, if you're looking at elk. So that's a commonly observed thing. And I think one of the biggest, there's probably multiple determinants. One of the big is how easy is it for you to lose heat? All right, because if you're thick, all right, that helps keep you warm. So that's an advantage up north, but that would be a disadvantage in Florida where you would overheat. You want to be smaller with a bigger surface area. So
Well, I enjoyed it.
thank you so very much. Have a wonderful day. I'll record it. We hope to see you in future ones. If you can't make it in person that week, remember these will be on Zoom as well, and I'll make recordings. Thank you very much. Have a wonderful day. Thank you, everyone online. Any questions here? Let me just check the chat. Well, okay, just trying to get. Thank you for all the comments in the chat. Go bird, go birds. Okay, yeah, I'm from Philly too. Yeah. Okay. Thank you, everyone. Yes, you had a question.
I wasn't here last week and I was trying to find online the recording from last week's.
Yes.
So I have to send you an email to get that?
You
or
don't.
is
Well,
it
could you
on-
just give me a second? 3,
Sure.
6, 9, 12. Okay. So this is the first time we're doing something like this, and we're a little disorganized. So there will probably be other places. However, if you were to go to Dr. Jan 41
Yes, got that down.
and then go to playlists,
In your playlist. Okay.
right? The first one, if I make another one anytime soon,
So it'll look like. this.
it'll say Birds of Orange County lecture series,
Got
and there's only one video there so far.
I would be able to.
Thank
figure
you.
that out.
Thank you.
Gotcha.
But I'll be adding to these every.
Gotcha. Thank you. Very interesting.
Thank you. Good night, everybody.
Yeah, I've noticed I'm like the only young adult here. Do you know